Hello, algebra students. Today we're going to start doing more work with radicals. So far we've simplified radicals. We had square roots, we had cube roots, we had 1/2 and 1/3 powers that we changed into square roots and cube roots. But today we're going to start with multiplying radicals. So if I give you two different things, and I know these radicals look kind of weird. If I have the square root of a times the square root of b, I can put those two together into one square root, just have the square root of that product. So I can just multiply the numbers and have them both inside the square root. We have some options when we're doing this, so we have to be aware of that to look for the easiest way to solve these problems, but just know that you can always multiply those radicals together. So I'm going to suggest very strongly that you write these examples down in your notebook. Pause the video if you need to, but I want to make sure that you are getting some practice with these. In number 1, square root of 3 times the square root of 5, that would, just using our rule, go together and become the square root of 15. Now, square root of 15, there's nothing in there that I can simplify, right? If I wanted to try to make a factor tree, the only thing I can think of besides 1 and 15 would be the 3 and the 5, right? If I would do this, well, there's no pairs there. So that didn't make any sense to do that because it's just going to go right back together. So actually, this problem is totally simplified. If I leave it as the square root of 15, that problem's just done. In number 2, notice that I've got negatives outside of both of the radicals. And a negative times a negative is going to be a positive. So in fact, I can kind of ignore those two negatives. So the square root of 18 times the square root of 2, if I would multiply those two together, I would get the square root of 36. Now, we've talked about problems like this. You could make a factor tree for 36. There's a couple ways that I can think of to do it. However, the square root of 36 is just 6, right? 6 times 6 is 36. And if you did want to make a tree, and there are more than one ways to do this, I said, you could do that. Oh, look, I've got a pair. It's just a 6. It breaks out. There's nothing left over. I wouldn't even need to see this work personally. You can certainly have it, but if it's a perfect square, you don't need to do that. I'm not going to show you another way to do this particular problem, but I will say you don't have to multiply them together. I mentioned on the very first slide that there are other ways to do this. However, when I multiply the 18 times 2, it does give me a perfect square. In this problem, this is the best way to do this. I would definitely multiply them together because that square root of 36 is so nice to deal with. In number 3, I have a number on the outside. That 3 that's on the outside, that's just going to kind of tag along until the very end. 2 is not a perfect square, 14 is not a perfect square. So I would put those two together. I'm going to keep that 3 on the outside. 2 times 14 is going to be 28. Now I want to make a factor tree from 28. You could break it right back down to 2 and 14. That'd be fine. I'm guessing, though, that most people would go with 4 and 7. The 4 is going to give me a 2 and a 2, so there's a pair that'll break out. The 7 is prime. There's no matching number to go with that, so it's just going to stay inside the radical. So I had the 3 on the outside. I'm going to break that 2 to the outside, and there's my 7 that's left over. This would give me 6 times the square root of 7. Let me show you on this problem the other option that you have. Let me just rewrite this problem. 3 square root of 2 square root of 14. Instead of putting the 2 and the 14 together to make 28, I could just make trees from each of my numbers, and then just anything that's under one of those trees can get circled up. So 2 is actually done. There's nothing I can do with that. But the 14, I could make that a 2 times 7. And now I can say, oh, right there, there's a pair. The first 2 was underneath a radical. The second 2 was from the 14, which is under a radical. So I have my 3 on the outside. I break the 2 to the outside, and there's still my 7 that's left over. So you have options of either putting it together into one radical or just make trees from each of the numbers and then grab any pairs that you want that are under the radicals. In number 4, the radical parts, the square root of 3 and the square root of 2, neither one of those simplify. There's no pairs that I can possibly get just from the stuff in the radicals. So what I would do is I would multiply the 5 and the 7 together to get 35 on the outside. And then I would put these two together into here, which gives me 6. That wasn't a very good arrow there. I guess I don't even really need an arrow. It's just this 3 that's in the radical and this 2 that's in the radical just go together to make 6. So it's just 35 rad 6. In number 5. Again, I have numbers on the outside of the radical. That -2 and the +3, those are just going to kind of pull out in front. The 18 times 8, if you multiplied 18 times 8, you do actually get a really nice number that probably most people wouldn't check, because I just said, hey, you don't really have to multiply them together. 18 times 8, not super easy to do in your head. So I could see doing this problem with 2 separate trees, right? The 18 can be 9 times 2. This will be a 3 and a 3. Well, there's a pair. The 8, we've done that so many times that I can do this. So I've got another pair of 2's right there, and I've got a pair of 2's right there. So I had a -2 on the outside. I had a 3 on the outside. Then I'm going to break this 3 out, and I'll break that 2 out, and I'll break that 2 out. And there's nothing left in the radical. So now I just have to multiply all of this mess together. So if I would have the 3 times 3 is 9, 2 times 2 times 2 is 8, and it's a negative. So -72. Here's the other option. If you looked at this and you realized that 18 times 8 was a really nice number, you could have the -2 and you could have the 3 that were on the outside. If you multiply 18 times 8, that's 144. So you'd have -2 times 3 times 12, which also gives you -72. So you can see there's different ways to do these kind of problems. Not that there's one right way that you're always going to use. You just have to be looking for which way might be easier, but realize even if you don't pick the easy way, it'll still work. In number 6, the 6 and the 7, so the 6 I can make a little tree and make a 2 and a 3. But I don't see any pairs there. So I'm going to just put this stuff together. So I'm going to have the 2 and the -3 on the outside. And then the 6 and the 7 are both going to multiply together to become a 42. So this is going to be -6, rad 42. So many people see 42 and you think, oh, it's such a big number. There's got to be pairs in there, right? And 42 actually doesn't have any pairs. If I would split it up to be the 6 and the 7 that I started with, the 6 is going to be a 2 and a 3, and there's a 7. There's no pair that I can grab out of that to make that simplify any more than what I have. So it's just going to be rad 6, or -6 times the square root of 42. Here's some new stuff. Still multiplication, but this is a distribution problem. We know how to do distribution. That's not a problem. We just haven't done it with radicals before. But now we know how to multiply radicals. So the 2 times the 3, that part's easy, that's just 6. Plus, this is not rad 10. The 5 is in a radical, but the 2 is not. So the 2 would stay outside the radical. The 5 stays inside the radical. And that doesn't simplify. Rad 5, there's nothing I can do with that. And the 6 plus the 2, so this is a trick question. Can I add the 6 plus 2 and make it 8 rad 5? No. That rad 5 is almost like a variable. This would be like 6 plus 2x. You can't combine those because they don't match. So this one's just done exactly the way that it is. For number 8, when I multiply here, you'll find some tricks along the way, but for right now, let's just multiply this and put it together into one radical. So the square root of 3 times the square root of 3 is going to be the square root of 9. The square root of 3 times 6. Now remember, the 6 is a regular number. There's my rad 3. Rad 9, the square root of 9, make a tree if you need to, but you should know that the square root of 9 is just 3. And that one's done. Again, I can't add these. I can't do the 3 plus 6 part because this is kind of like 3 plus 6x. Pretend that that radical is like a variable. It doesn't match. They're not like terms, so I can't do anything more with that. And for this distribution, rad 2 times 7, remember the 7 is just a regular number, so it's going to stay on the outside. 7 rad 2. These are both radicals. So rad 2 times rad 6 could be rad 12. However, we can't stop there. Not just because they both have radicals. The radicals don't match. I can't combine these. But rad 12 does simplify. I could go with 4 times 3. Gives me a pair of 2's right there. So the 7 rad 2 didn't change. The second part, though, the 2's are going to break out, and the rad 3 is going to be left over. And again, these don't go together. Just because they both have radicals doesn't mean that they're like terms. This is like 7x plus 2y. They don't match. We're done. And number 10, we just simplified on the last problem, the square root of 12. We know that there's going to be some stuff in there that can work. You could simplify the rad 12 first, or you can just distribute it the way it is and simplify each part when we're done. So when I multiply this part, the 2, remember, is a regular number, 2 rad 12. Plus, rad 12 times rad 3 is going to be rad 36. Now, rad 36 is nice. Again, square root of 36 is just 6. I don't need to make a tree if I know that it's a perfect square. But this part I do need to clean up. And I just did it in the last problem, so you could totally just use that work again. So I had a 2 on the outside. I'm going to break out this pair of 2's to become a regular 2. There's my rad 3. The square root of 36 we said is just 6. So this would be 4 rad 3 plus 6. Today's worksheet is multiplying radicals. The answer keys in Schoology. Take the formative in Schoology. Take your time. Please don't try to do this all in your head. Show some work on paper. I promise it will help you. And if you need any more help than that, let me know.